Determine the resistance of each of the following resistors. We have Roman 1, brown, red, blue, and no color band. And Roman 2, we have green, violet, white, and gold. So this is about the color coding of resistors. And in order to get this kind of a question, you have to know the following table, because it is not given in the exams. So you have to know this table. And the table looks like this. We have the color. This is color coding for fixed resistors. So we have the color. We have the significant figures. We have the multiplier. We have the multiplier, and we have the tolerance. So the first color is silver. The second color is gold. We have black. We have brown. We have red. We have orange. We have yellow. We have green. We have blue. We have violet. We have gray. We have the white. And lastly, we have none, whereby we don't have any color. So none means no color at that point. Now for the significant figures, we don't have for the silver, and also we don't have for the gold. For the black to white, you start from 0 from black. So black is 0. Brown will be 1. Red 2. We have 3. 4. We have 5. We have 6. We have 7. We have 8. And we have 9. And for the none, we don't have any significant figure. So that is how you have to label the significant figures. You leave for silver and gold. Then you start from 0 from black to white, which is 9. Then for the multiplier, from silver, we start with power of -2. We go to power of -1. So we start from power of -2 and increase. So at 0, we have 10 power 0, and any number power 0 is 1. Then we continue with 10 power 1. This will be 10 power 2. Actually, the power corresponds to the number which is here. So for the orange, it will be power of 3, power of 4, 5, etc. So this will be power of 3, power of 4, we have 5, we have 6, we have 7, we have 8, we have 9 for this, and for the none, we don't have anything. So for none, you can leave it. We don't have for none. We go to the tolerance. For silver, it is plus or minus 10%. Next is 5%. Then this one don't have, which is the black. Black don't have any tolerance. Then we go with 1%. We go to 2%. Then for the orange and yellow we don't have, so we skip this, and also we skip this one. Then for the next color, which is power of 5, which is yellow, it is not yellow, which is green. Green has 0.5. We have 0.25. This is plus or minus. Then we have 0.1. Then we skip for gray and white. And for the none, we normally have a plus or minus 20%. Plus or minus 20% for the none. Now, let's use this table and see how we determine the value of our resistors which have the given colors. So from this table, the first resistor has 3 bands, but the 4th band is not present. So actually, this is how you go about it. For 3 bands resistor, I mean when we have some specific colors, it means the 4th one is not there, and this is the case where we have now in our Roman 1. So in this case, the first and second bands will be read from significant figure column. You read it from the significant figures column. Then the 3rd band, you read it from the multiplier column. Then for the 4th band, because we don't have any color, we will consider the none, which is our last row in our table. So we consider the none. So we read from the none row, which is now, you read from the none row, which is now the tolerance. So in short, the 4th band, which is no color here, will represent the tolerance. So let's check now from our table how this is achieved. We have brown, red, blue, and no color band. So from our table, for brown, in significant figures, because it is the first band, for the brown we read from significant figure, and for the red also from the significant figures. So we have brown, red, and we have blue and no color. So for this, we read the value that corresponds to brown in the significant figure, which is 1. So we have 1. For red, it is 2. Then for blue, we read the multiplier, which is the third band. This is a multiplier of blue is a multiplier of power 6. So this is 10 power 6, and no color has a tolerance of 20%. So for no color, we have 20% tolerance. So this will give us 12 times 10 power 6 plus, or this is ohms. Actually, this is in ohms, and a plus or minus 20% tolerance. That is the first case. In the second case, we have 4 bands. So we shall read from green will be significant figure. The first 2 bands are for significant figures. That is for 4 bands. So for 4 bands, the first and the second, you read it from the significant figures. The third one is the multiplier, and the fourth one is the tolerance. When we have 5 bands, you take the first 3. The first 3 colors, you read it from the significant. Then the other one, the fourth one goes for the multiplier, and the fifth one, the tolerance. So we have green, we have violet, we have white, and we have gold. Let's check for green and violet from significant figures. Green is 5. Green is 5. Violet is 7. So we have 7. White, we will go for the multiplier, and the multiplier of white, white is the last one here, which is 10 power 9. And gold, we read the tolerance, and tolerance for gold is plus or minus 5%. So gold is plus or minus 5%. So you write like 57 times 10 power 9. This is ohms, plus or minus 5% tolerance. So that is how you find the values for resistance, or how you find the resistance of a resistor using the color coding table. So this table, you have to know it once you are going for an exam.